Question 1. Given the circumstances, Isli has written a Perl script that reads data from a file and processes each line to store key-value pairs in a hash. However, she notices that some keys are being overwritten unexpectedly. The script uses a global hash %data and reads lines in a loop where keys are extracted dynamically. What is the most likely cause of the problem, and what should Isli do to prevent accidental overwriting of keys in her hash? A. She should declare the %data hash as my %data inside the loop to limit its scope and prevent overwriting. B. The problem arises because she is not using a multidimensional hash. She should convert %data into an array instead. C. Overwriting occurs because the keys are not unique. She should ensure keys are unique before inserting into %data. D. She should clear %data at the start of each loop iteration to prevent data accumulation. Answer. Correct answer. See explanation. In Perl, hashes store key-value pairs where each key must be unique. If Isli's keys are dynamically generated and not unique, inserting new key with the same name will overwrite the existing value, which explains the data loss she observes. Declaring %data with my inside the loop option A would reinitialize the hash on each iteration, losing all previously stored data, which is not the intended behavior. Using arrays instead of hashes option B would lose the key value mapping benefits. Clearing the hash each iteration option D would erase prior data unnecessarily. The correct approach is to ensure keys are unique or to design the data structure to allow for multiple values per key, e.g., using arrays or references. This understanding relates to Perl's core hash behavior as described in Perl data and Perl documentation. Question 2. Under the assumption that Istigasi uses the my keyword to declare variables inside a subroutine, but then tries to access those variables outside the subroutine, what will happen and why? A. The variables will be accessible globally because my variables have package-wide scope by default. B. The variables will not be accessible outside the subroutine because my variables have lexical scope limited to the block where declared. C. The variables will be accessible only if declared as the files beginning outside any subroutine. D. Perl will throw runtime error when accessing the variables outside their scope. Answer. Correct answer. B. Explanation. The my keyword in Perl declares variables with lexical scope, meaning the variables exist only within the block file or eval where they are declared. Thus, variables declared with my inside a subroutine are private to that subroutine and cannot be accessed outside it. This is critical for encapsulation and avoiding unintended side effects. Option A is incorrect because my variables are not package global. Option C describes variables with lexical scope at file level, which are visible throughout the file, but still not globally outside. Perl does not throw an error accessing an undefined variable outside the scope. It simply treats it as undefined. Option D. This concept is detailed in the Perl documentation on variable scoping. Perl is a Perl X1. Question 3. When considering input from the user through the command line, Ister writes Perl script that processes argv. He wants to ensure that his script behaves correctly when no arguments are passed. What is the best way to check for the presence of command line arguments and provide useful error message? A. Check if #argv is greater than or equal to 0 and print message if false. B. Check if argv is defined and if not, exit with an error. C. Use defined arg to test if any arguments exist. D. Use the scalar function on argv to check if its size is 0, then display an error message. Answer. Correct answer. D. Explanation. Argv is an array holding the command line arguments. To check if arguments exist, use scalar argv, which returns the number of elements in the array. If this is 0, no arguments were passed, so the script should inform the user or exit. Option A uses #argv, which returns the highest index, so it is -1 if empty, while valid it is less clear than scalar argv. Option B is incorrect because arrays are always defined. A checking defined on an array does not indicate content presence. Option C is invalid. A defined does not work directly on arrays to check content. This approach aligns with best practices in Perl script processing command line input, perlrun, perlvar. Question 4. As demonstrated by recent Perl scripts, Kumar attempts to substitute all occurrences of the word color with color in text file, but only the first occurrence per line is changed. What adjustment should she make in her substitution statement to replace all occurrences on every line? A. Add the G modifier to the substitution operator like color. B. Use the M modifier instead of G. C. Replace the substitution operator with regular expression match operator. D. Use the S operator inside for each loop without modifiers. Answer. Correct answer, A. Explanation. In Perl, the substitution operator S replaces only the first occurrence of the pattern per string by default. To replace all occurrences, the global modifier G is required, which applies the substitution repeatedly through the string. The M modifier changes the behavior equals incurs in multi-line strings and does not affect substitution repetition. Replacing S with a match operator would not perform substitution. Or, using a loop without the G modifier is inefficient and unnecessary. This understanding is key to Perl's regex mechanics and substitution operations. Perl, Perlup. Question 5. During the process of writing a loop, Mr. White wants to exit a nested loop early only if a certain condition is met inside the inner loop. What is the best Perl statement to immediately exit only the inner loop without terminating the outer loop? A. Use last inside the inner loop. B. Use next inside the inner loop. C. Use exit to terminate the entire program. D. Use redo inside the inner loop. Answer. Correct answer, A. Explanation. The last statement in Perl immediately terminates the innermost loop it is in and continues execution after the loop block. Thus, it is the correct control structure to exit only the inner loop early. The next statement skips the current iteration and proceeds to the next one inside the same loop, not exiting the loop itself. Exit terminates the entire script, which is not desired here. Redo restarts the current iteration of the loop without evaluating the condition, which is also not the goal. This loop control behavior is fundamental in Perl flow control. Perlson. Question 6. Considering the evidence is new and wants to ensure that a variable count always holds a numeric value, but it is currently declared as a scalar that can hold strings or numbers, which Perl approach or operator should she use to safely enforce numeric context on count without changing the variable's value? A. Use the int function to cast count to an integer. B. Add 0 to count like count equals count plus 0. C. Use the scalar function on count. D. Apply the chomp function to count. Answer. Correct answer. B. Explanation. In Perl, variables are context sensitive and adding 0 count plus 0 forces numeric context without altering the value itself. This is a common idiomatic way to ensure the variable behaves as a number even if originally a string. The int function converts to an integer but also truncates decimal values, potentially changing the original value. The scalar function just returns the scalar context expression and does not enforce numeric conversion. Chomp removes trailing new line characters and has no numeric effect. This relates to Perl's context-sensitive variable behavior described in Perl data and Perlvar. Question 7. The primary reason for Mr. Brown's subroutine failing to accept passed parameters correctly is that he equals assign the subroutine but forgot to assign its values to local variables. What is the best practice for handling passed parameters inside a Perl subroutine? A. Use shift to extract parameters equals and assign them to my variables. B. Ack equals rectly everywhere without assignment. C. Declare parameters globally to avoid scope issues. D. Use local instead of my for parameters inside the subroutine. Answer. Correct answer, A. Explanation. In all equals is the array containing the parameters passed to a subroutine. Best practice is to immediately extract parameters equals as a shift or list assignment into lexical variables declared with my. This ensures clean scope readability and prevents accidental modification of access equals directly. Option B is error-prone and reduces clarity. Declaring parameters globally, option C, breaks encapsulation and is bad practice. Using local, option D, is for temporarily overriding global variables and is not intended for parameters. This is clearly documented in PERL-sub. Question 8. By evaluating the following Perl snippet, Singh wants to determine if the scalar variable str contains only digits. He uses the rigid cr equals e plus. What does this expression verify and why is it appropriate? A. It verifies if str contains at least one digit and nothing else, ensuring numeric content. B. It matches if str contains digits anywhere but may contain other characters. C. It checks if str starts with a digit but ignores the rest. D. It matches if str contains only whitespace. Answer. Correct answer A. Explanation. The reject key equals Z asserts the start of the string. D plus matches one or more digits. C equals asserts the end of the string. Together they verify that the entire string consists solely of digits with no other characters or white space. This is the standard way to validate numeric-only strings in PERL regex. Option B would be true if it equals Incas we used. Option C ignores the enango, which is not the case here. Option D is unrelated to digits. This aligns with PERL's powerful pattern matching capabilities described in PERL return PERL. Question 9. Mr. Evans writes a PERL script that uses push to add elements to an array list. After pushing, he wants to retrieve the last element without removing it. Which function should he use and why? A. Use poplist to get the last element. B. Use list 1 to access the last element without modifying the array. C. Use shift list to get the first element. D. Use and shift list to prepend elements and access the first element. Answer. Correct answer. B. Explanation. List 1 accesses the last element of an array by negative indexing without modifying the array. Pop option A removes and returns the last element, which holds the array. Shift and unshift options C and D manipulate the beginning of the array and do not pertain to accessing the last element. This understanding of array indexing and manipulation is fundamental in PERL data structures, PERL data, PERL func. Question 10. From a practical standpoint, Is Alvarez wants to include comments in her PERL script that span multiple lines for better documentation. What is the correct and most efficient way to include multi-line comments in PERL? A. Use pound at the start of each line to comment multiple lines. B. Use the star-style comment block as in C language. C. Enclose comments inside equals pod. Cut pod documentation blocks. D. Use double quotes around multiple lines to comment them out. Answer. Correct answer. C. Explanation. PERL does not support traditional block comments like start. The most efficient way to include multi-line comments is to use pod, plain old documentation, blocks with equals pod to start and equals cut to end the comment block. This is passed as documentation, ignored by the interpreter, and widely used in PERL scripts for extended comments. Option A is valid but less efficient and visually cluttered for large comments. Option B is invalid in PERL. Option D treats the text as a string, not a comment. Understanding pod is crucial for PERL documentation and scripting best practices. PERL pod. Question 11. In the context of PERL's variable scope, Mr. Adams declares a variable counter using local inside a subroutine that is called multiple times recursively. He observes that counter retains its value across recursive calls, which causes incorrect counts. What is the main reason for this behavior, and what should Mr. Adams do to ensure each recursive call gets its own independent counter variable? A. Local creates a temporary global alias, so he should use my to create a lexically scoped variable instead. B. Local creates a lexical variable, so he should use our instead to make it global. C. Local variables are private and do not retain values, so the problem must be elsewhere. D. He should declare counter as a constant to ensure it does not change. Answer. Correct answer A. Explanation. In PERL, local temporarily saves and replaces the value of a global variable, package variable, for the duration of the current block and any called subroutines, effectively creating a dynamic scope. This means recursive calls share the same underlying global variable, leading to unintended value retention. Conversely, my declares a variable with lexical scope. Each recursive call gets new independent copy, which solves the counting issue. Option B is incorrect, as our declares global package variable. Option C misinterprets local, declaring as constant. Option D doesn't apply. This concept is key in understanding PERL variable scoping rules. PERL var, PERL sub. Question 12. According to recent studies, Is Dias writes a PERL script to parser a fee using the split function with a comma delimiter. However, she notices that fields enclosed in double quotes containing commas are incorrectly split. What is the underlying cause, and how should Dias handle CSV parsing correctly in PERL? A. Split does not handle quoted fields correctly. She should use the text CSV module instead. B. She should increase the number of fields in split to handle quoted commas. C. Using split with A automatically ignores commas inside quotes. D. Changing the delimiter in split to will solve the issue. Answer. Correct answer A. Explanation. The split function splits strings byte. a fixed delimiter and does not understand CSV quoting rules, such as fields enclosed in double quotes that can contain commas. This causes misinterpretation of field boundaries. The correct approach is to use specialized modules like text CSV, which properly parse CSV files, honoring quoted fields and escaping rules, increasing split fields or changing delimiter. Options B and D won't handle quoted commas correctly. Option C is false because split has no built-in awareness of quoting. This highlights the importance of using appropriate PERL modules for complex text parsing, text ESE, and documentation. Question 13. Within the framework of regular expressions, Mr. Thompson writes, a pattern to extract an email address but finds it matches partial addresses embedded in other text. He wants to ensure the rejects matches only standalone email addresses. Which of the following modifications would best restrict the match to whole email addresses only? A. Use word boundary anchors B around the email pattern. B. No keywords anchors to match only at the start and end of the string. C. Use the G modifier to find all email matches in the string. D. Use the substitution operator S instead of matching. Answer. Correct answer A. Explanation. Word boundary anchors B in PERL rejects assert a position between a word character W and a non-word character, effectively isolating whole words or tokens. Placing B around the email pattern ensures it matches only complete email addresses, not partial substrings embedded in longer strings. Anchors and option B restrict matches to entire string start and end, which is too strict for emails and longer text. The G modifier, option C, controls global matching but does not restrict partial matches. The substitution operator, option D, is unrelated. This emphasizes the role of anchors and boundaries in PERL rejects PERL. Question 14. Taking into account the use of file handles, Wilson wants to read from a file line by line safely. She opens a file with a file name, but her script fails to handle file open errors gracefully. What is the best practice to open files in PERL to ensure error handling and good resource management? A. Use the 3-argument form of open with a lexical file handle and check the return value with or die. B. Use open without checking the return value. PERL will automatically handle errors. C. Use global file handles and avoid lexical scoping for portability. D. Always open files in binary mode by adding and raw to the mode. Answer. Correct answer A. Explanation. The recommended practice is to use the 3-argument form of openE. G. Open me file name or die cannot open file name. But using lexical file handles, my FH limits scope and improves safety. Checking the return value allows the script to handle errors gracefully. Option B is unsafe as PERL does not automatically abort on open failure. Option C encourages older, less safe global file handles. Option D is only needed for binary files, not text files. This approach is documented in PERL's best practices for file EO, PERL Func, PERL OpenTut. Question 15. From the perspective of subroutine design, Mr. Patel wants to write a reusable function that can accept a variable number of arguments, including optional parameters. What is the most PERL idiomatic way to handle optional and named parameters in subroutines? A. Pass arguments as a hash or hash reference and unpack inside the subroutine. B. Use fixed positional parameters only and ignore extra arguments. C. Declare multiple subroutines for every possible combination of parameters. D. Use global variables for optional parameters. Answer. Correct answer A. Explanation. Passing parameters as a hash or hash reference is a common PERL idiom to support named and optional parameters. This allows arguments to be passed in any order, making the subroutine flexible and clear. Inside the subroutine, the hash keys can be checked for presence or default values assigned. Fixed positional parameters, option B, lack flexibility. Creating multiple subroutines, option C, is inefficient and unmaintainable. Using global variables, option D, breaks encapsulation and is discouraged. This approach aligns with PERL subroutine best practices, PERL sub. Question 16. Given the circumstances that Mr. Johnson's PERL script uses the print function to output to file, but notices inconsistent output due to buffering, what is the recommended method to ensure immediate flushing of the output buffer after each print statement? A. Set the special variable equal to true value for the output file handle. B. Use flush function after every print. C. Use bin mode on the file handle. D. Close and reopen the file handle after each print. Answer. Correct answer, A. Explanation. The special PERL variable controls output buffering for the currently selected file handle. Setting U equals 1 forces PERL to flush the output buffer immediately after every write or print, ensuring timely output. There is no built-in flush function in PERL. Option B. Bin mode. Option C sets binary mode for file handles, but doesn't affect buffering, closing, and reopening file handles. Option D is inefficient, unnecessary. This is fundamental to PERL EO buffering behavior. PERL var PERLit. Question 17. While examining code reuse techniques, Garcia attempts to include external PERL code by using the require statement, but the script fails to locate the module. What is the best way to ensure PERL finds the module and imports it correctly? A. Add the modules directory to inc, or use the uselib pragma before require. B. Rename the module file to PL extension. C. Use do instead of require. D. Place the module in the current working directory without changing inc. Answer. Correct answer, A. Explanation. PERL searches for modules in the directories listed in the inc array. If a module is not in these directories, it won't be found. The best practice is to add the modules directory to inc using uselib after module before calling require or use. Renaming the module file, option B, does not solve the path problem. Using do, option C, loads and executes the file, but doesn't handle dependencies or version checks. Require does. Relying on the current working directory, option D, is not reliable or recommended. Understanding inc is critical to PERL module management. PERL nadlib, PERL run. Question 18. The fundamental question is why Mr. Martin's PERL script that uses for each to iterate over an array does not reflect changes made to array elements inside the loop. What is the correct explanation and how can you modify elements within for each loop? A. For each aliases each element. In modifying the loop variable modifies the array directly, so no change is needed. B. For each copies each element into the loop variable, so modifying the variable doesn't affect the original array. Use indexes instead. C. Using for instead of for each fixes the problem. D. Declaring the loop variable with my inside the loop will update the original array. Answer. Correct answer, A. Explanation. In PERL, the for each loop creates an alias to each element of the array during iteration, meaning modifying the loop variable modifies the original array element. If changes are not reflected, it often means the loop variable was redeclared my inside the loop or another issue. Option B incorrectly describes for each. Using for is a synonym of for each, option C, and doesn't affect aliasing. Declaring the loop variable inside the loop, option D, shadows the alias and prevents modifications from propagating. This concept is covered in PERL looping and references a PERLSyn PERLref. Question 19. Based on the information that Mr. Lewis wants to debug a PERL script and track warnings and errors, which of the following is the most effective way to enable strict syntax checking and warnings? Use the pragmas use strict and use warnings at the beginning of the script. B. Pass W switch on the command line only without changing the script. C. Add use diagnostics only without strict. D. Run the script without any additional switches and rely on error messages. Answer. Correct answer, A. Explanation. Using use strict enforces strict variable declaration and other compile time checks while use warnings. It enables runtime warnings, making scripts more robust and easier to debug. Relying on the W switch, option B, is less flexible and not recommended in modern PERL. Use diagnostics, option C, provides verbose warning explanations but depends on warnings being enabled first. Option D, lacks proactive error catching. This practice is foundational to clean PERL coding, PERL pragma, PERL DEC. Question 20. While analyzing Mr. Roberts' script, it is observed that he uses the chomp function incorrectly by applying it to an array rather than scalar variables. What will be the outcome of this usage, and what is the correct usage of chomp to remove new line characters effectively? Chomp can safely be applied to arrays. It will remove new lines from each element in place. B. Chomp only works on scalars. Applying it to arrays causes a runtime error. C. Chomp only works on hashes, not arrays. D. The correct way is to loop over each element of the array and apply chomp individually. Answer. Correct answer, explanation. In Perl, chomp can be applied directly to an array and it will remove the new line character from each element in the array in place. This is efficient and idiomatic. It does not cause a runtime error. Option B is false. Option C is unrelated. Option D is unnecessarily verbose compared to the direct array usage. Understanding chomp's behavior with scalars and arrays is essential for text processing. Perlfunc. Question 21. With respect to Perl's handling of arrays, Isis Lopez writes subroutine that receives an array as parameter. Inside the subroutine, she modifies the array elements. When the subroutine returns, she notices the original array outside the subroutine remains unchanged. What explains this behavior, and how can she modify the original array elements from within the subroutine? Arrays passed to subroutines are passed by value. She should pass reference to the array to modify it in place. B. Perl automatically passes arrays by reference, so the issue must be with scoping. C. Modifying the array inside the subroutine requires using the local keyword. D. She should declare the array without to allow modification in subroutines. Answer. Correct answer A. Explanation. In Perl, when an array is passed to a subroutine, it is flattened into the equals array, effectively passing by value copy of elements. Changes made to this copy inside the subroutine do not affect the original array. To modify the original array, the subroutine should receive a reference to the array e.g. myArrayRef equals shift, and dereference it when modifying elements. Options B, C, and D misunderstand Perl's passing mechanism and scoping rules. This distinction is critical in Perl data handling and subroutine parameter passing. Perl sub, PERLref. Question 22. When analyzing control flow, Mr. Clark writes a loop using the while statement to read from a file handle line by line. However, he notices the loop terminates prematurely if a blank line is encountered. Why does this happen, and how should he correct it? A. The loop condition evaluates the input in scalar context. A blank line is still true, so the problem is elsewhere. B. The loop uses while, which returns undef only at eoff. The blank lines are true, so he likely misused chomp. C. Using while returns false on blank lines, so he should use defined to test instead. D. He should avoid using while for file reading and instead use for. Answer. Correct answer. B. Explanation. In Perl, the while loop reads the next line in scalar context. It returns undef only at eoff, so blank lines, which contain just a new line, evaluate as true and do not terminate the loop prematurely. If the loop is terminating early on blank lines, it may be because the script mistakenly tests the line content rather than the read operation result. Proper reading should be done with while, an optional use chomp to remove new lines. Option C misunderstands that while returns false only at eoff. Option A incorrectly assumes blank lines cause the issue. Option D is irrelevant. This subtlety is documented in Perl file handle reading Perl OpenTut. Question 23. The underlying principle of Perl's map function is to transform lists. Mr. Sanders wants to convert list of strings to uppercase using map. Which of the following is the correct usage and why? MyUpper equals map equals it because map applies the block to each element and returns the transformed list. B. Mapup list because map works directly on arrays without needing block. C. MyUpper equals map list because UP should be called after map. D. Use for each loop instead because map cannot transform lists. Answer. Correct answer A. Explanation. The map function takes a block or expression and applies it to each element of a list, returning a new list with the transformed values. Map equal list correctly converts each element to uppercase. Option B is invalid syntax because map requires a block or expression, not just a function call on an array. Option C applies up to the entire list returned by map, which is incorrect. Option D ignores the power of map as a functional programming tool in Perl. This is a foundational aspect of list processing in Perl. Perlfunc. Question 24. During the process of writing a Perl script, Bennett uses the die function after opening a file to handle errors. She notices that die outputs the error but does not provide the system error message. How can she modify her die statement to include the system error message? G. File not found. A. Use die. Can't open file to append the built-in error variable. B. Use die. Error because Perl automatically adds the system error. C. Use warn instead of die for error messages. D. Use die. Can open file or for error handling. Answer. Correct answer, A. Explanation, is a special Perl variable that holds the current system error message (NO) after a failed operation like open. Concatenating to the die string provides detailed system-level error info, improving diagnostics. Option B is false. A Perl does not add error messages automatically. Option C only warns but does not stop execution. Option D is incorrect Perl syntax. Proper error handling with die is essential for robust Perl scripting. Perl Perlfun. Question 25. For the purpose of regular expression optimization, Mr. Johnson uses a greedy quantifier star to capture a portion of a string but finds it captures too much. What is the best way to limit the match to the shortest possible substring? A. Use the non-greedy quantifier star to match as few characters as possible. B. Replace star with plus to capture at least one character. C. Use the G modifier to globally match multiple times. D. Use the anchor to restrict the start of the match. Answer. Correct answer, A. Explanation. Greedy quantifiers like star match as much text as possible, often overshooting intended substrings. The non-greedy version star matches as little as possible while still allowing the overall pattern to match. This rejects captures more precise. Option B changes minimal matching but remains greedy. Option C controls global matching, not greediness. Option D anchors the start but doesn't affect quantifier greediness. Understanding greedy versus non-greedy quantifiers is key in Perl rejects Perl. Question 26. Given the circumstances, Isha wants to ensure that her Perl script exits immediately upon a failed module import using use. She notices the script continues despite missing modules. What is the reason and how can she enforce an immediate fatal error on failed imports? A. Use performs a compile time check and dies on failure. If script continues, error handling may be masked. B. Use only warns on failure. She should use require for fatal errors. C. She should equals if they use to catch errors manually. D. Use eval around use to handle errors gracefully. Answer. Correct answer, explanation. Use is executed at compile time and will die with a fatal error if the module cannot be loaded. If the script continues, it might be due to eval blocks or exception handling that catch the error and suppress termination. Option B is wrong. Require loads at runtime but also dies on failure. Checking option C is relevant only inside an eval block. Wrapping use in eval. Option D allows error handling but is contrary to immediate exit behavior. Understanding compile time module loading is essential in Perl. Perlmod, Perlfun. Question 27. Taking into account Perl's logical operators, Mr. Nguyen writes compound conditional statement as equals and without parentheses. What potential issues could arise, and what is the best practice to ensure the intended evaluation order? A. Operator precedence may lead to unexpected results. Always use parentheses to clarify. B. Perl evaluate all operators left to right regardless of precedence. C. Using an and or keywords is always preferred or equals and. D. No issues arise because of course was ear precedence then. Answer. Correct answer A. Explanation. In polyuls is here precedence then, but mixing them without parentheses can cause unexpected logic. To avoid ambiguity and ensure the intended condition order, parentheses should be used explicitly. Option B is false. If Perl respects operator precedence. Option C suggests and or which have low precedence and different behavior, but precedence issues still remain without parentheses. Option D recognizes precedence but neglects that this can cause bugs if misunderstood. Proper use of parentheses improves code clarity and correctness. Perl. Question 20. In a situation where Mr. Davis wants to iterate over a hash to print all keys and values, he writes a for each loop over keys %. However, the order of keys printed is unpredictable. What is the reason and how can he print keys in sorted order? A. Hashes are unordered by nature. Use for each my key, sort keys %, to print sorted keys. B. Keys are stored in insertion order, so no sorting needed. C. Use values %, instead to get sorted keys. D. Use the each function to iterate in sorted order. Answer. Correct answer A. Explanation. Perl hashes are inherently unordered. Keys are stored and returned in an unpredictable order. To print keys in a sorted manner, you explicitly sort the keys. For each my key, sort keys %. Option B is false. The insertion order is not preserved. Option C, returns values, not keys. Option D, iterates over pairs but does not guarantee order. This behavior is foundational in Perl data structures. Perl hash. Question 29. From the perspective of performance optimization, Chang is comparing the use of split and rejects capturing groups for passing strings. What is a key consideration you should keep in mind regarding efficiency and flexibility? A. Split is generally faster and simpler for delimiter-based parsing, while rejects capturing groups offer more flexibility but can be slower. B. Rejects capturing groups are always faster than split. C. Split cannot handle complex patterns, so rejects capturing should be preferred regardless of speed. D. There is no performance difference between split and rejects capturing groups. Answer. Correct answer A. Explanation. Split is optimized for splitting strings based on delimiters and is generally faster and simpler for straightforward parsing tasks. Rejects capturing groups provide detailed matching and extraction capabilities, but may be slower due to complexity. Therefore, the choice depends on task complexity and performance needs. Option B is incorrect. Split is usually faster for simple splits. Option C overstates capturing groups necessity. Option D is false. Performance differences exist. This informs Perl text processing strategy. Perl-Funk. Question 30. When evaluating the merits of using the W switch versus use warnings, pragma in Perl scripts is that Alan wants to know the differences and best practice. Which statement is correct? A. Use warnings is preferred because it can be scoped and controlled lexically, unlike the global W switch. B. W enables more detailed warnings than use warnings. C. Both W and use warnings are identical in behavior and scope. D. W should never be used as it causes runtime errors. Answer. Correct answer A. Explanation. Use warnings is a pragma that enables warnings and can be applied lexically to specific blocks or files, allowing more granular control. The W switch enables global warnings for the entire script, which can be noisy and less flexible. Option B is false. Option C ignores scoping differences. Option D is incorrect. W enables warnings but does not cause runtime errors. Using use warnings is recommended modern Perl practice. Perl pragma.